Hey guys, Satyendra here, and in today's video we are going to create a spring in which both ends are grounded, and then spring is having a constant pitch, and then spring is flexible. Then what does this flexible means? It means when we assemble this spring in assembly, it should flex inside. If you see this assembly, here I have assembled the same spring 3 times between 3 different locations, and as you see, as the gap of plate varies, the spring height also varies, and as the spring height varies, the pitch of the spring varies. That means we can say that this spring is flexible and the spring is following the plates all the time. And other than this, some interesting thing like if you want to add some more coils at the ground end, just like this, you can see here there are 3 coils and 3 coils. So how to do this? So these many activities we are going to see in this video. So practically if you see any spring, it will be grounded both the end. You can see in this spring, and then the grounded area or grounded angle will be around 270 to 300 degree in between. So here in this spring, this area is around 290 degree. So to create this spring, we will use helical sweep, and there are 3 parameters in helical sweep to create a spring. Those are the first one is spring height, which you can see here. This is the spring height. It is 100. Then second one is the spring wide area, and then the third one is the pitch. So I'll just show you those parameters in this spring. As I edit this, the first one is spring height. So spring height you will get here. If I make it normal, this gap between this, if I switch on the planes, you can see the top plane, in between top plane to spring height, this length is the spring height. Say OK. So this is the first parameter. Then second parameter is the wide area. You see the wide area is here, it is 5. And then the third one is the pitch. So pitch is here. There are 2 different pitch value here. One is pitch 5 and the second one is pitch 20. So this kind of spring will be created by using variable pitch. And again, to add variable pitch in helical sweep, we have 3 different ways. First way is by value, then second way is by reference, and then third way is by ratio. But the most easiest way to do this is by reference method. So I will be doing this video by using by reference method, and later on I will explain other 2 methods also. So if you see this spring is around 180 degree grounded, but one more spring I have here. If you see this spring, it is around 290 degree grounded. So practically if you see any spring, that will be in between 270 to 300 degree grounded. So according to this spring is better than that. But what difference you have in these 2 springs, I'll just tell you. To create a grounded area, we have used this spring height plane and the top plane to cut the material in the top and in the bottom. Okay. So if you take the spring height in between these 2 planes, you see here the spring height is taken in between this top plane and spring height plane. So if you are taking a height like this, then you will get only 180 degree grounded portion, grounded area. But if you see this spring, Here I have taken little extra. I'll just show you. I have taken little extra. You can see here it is coming out of this reference. So I have taken little extra from both sides to make the area, grounded area, around 290 degree. So this is the trick actually. If you want to increase the grounded area, you need to take little extra both the ends. So to create this spring, I will be using helical sweep, and inside the helical sweep, to assign variable pitch, I will go for by reference method. So let's get started. I will directly go to new. I will type spring 3, say OK. I got this nice window. Now first I'll create one axis so that it will be helpful while assembling this spring inside the assembly. It is done. And then one plane I will create to specify the total height of the spring. I will not assign a direct value for the spring height. I will take these two references to specify the spring height. So I will just go for plane. I will take top plane as a reference and I will make it 100. The total length is 100. Okay. So you can see that one plane got created here. I will just rename it as spring underscore height. I have other data ready here. See, my spring height or spring length is 100, then wire die is 5, and then I need that constant pitch as 25. So I will try to maintain all these three values. So I have already created spring height as 100. Now I will directly jump to helical sweep. I'll select plane to specify the spring height. I'll say sketch, make it normal. Now I need the grounded angle as 280 or 290 degrees. So I'll just take this spring height plane as a reference and axis of revolution. Then I'll specify the total height. I will take little extra both sides as I told you. This will be 50 and this is the total height. So from this reference to this reference it is 100. I'll be taking little extra, but before that I will just create some reference point. I will use sketch point, or let us use this datum point. Okay, so here I have created 4 points. These points are the location to vary the pitch. See, by default we get 2 points. This is the start point for spring and this is the end point for spring. So the logic behind this is when you want to make your spring grounded, then the coil or the wire dia has to touch each other up to certain distance. So that distance, if my wire die is 5 and if it has to touch up to certain distance, then the first reference and the second reference gap should be equal to your wire die. So as I know that my wire die is 5, I will just take the distance from this point to this point is 5, and again from here to here is 5. The same thing, same distance I will create here also, and then one more dimension I will create from here till here. So this is the extra portion which will be added in the grounded area. Again, this side also I will create a dimension in the same way, because both the end has to be grounded, and from here till here. So I will assign all these things. Now I'll just make it equal, because this end and this end, if both ends are having grounded area, then it will be equal. So if I make this dimension equal to this dimension, then this dimension is equal to this dimension, and then this dimension is equal to this dimension. So if I make this 3 dimension equal, then it will reduce the relations which I am going to assign in the spring. So one more time I will just explain the logic. See, to touch the wire, because both ends are grounded, so to touch wire with each other, our starting pitch should be equal to the wire dia. So this value also I need to change. This value will be, this is somewhat 30% of the wire dia. So my wire dia is 5, then 30% of that will be 1.5, so just I'll type 1.5. Okay, so now once again I'll explain the logic. See, my spring is getting started from here. Okay, so here the in this location the pitch value should be equal to wire dia. This is the first point, this is the second point, and this is the third point. So if first point and second point points are having same pitch value as wire dia, then it will automatically touch. And from this second point to third point, from wire dia to the desired pitch, like here, from this point to this point, my pitch will be around 25, as my details are showing. The pitch value is 25. So from third point to fourth point, it will be 25. The pitch will be 25. So this value will be different, totally different than this. So to touch the wire with each other from first point to second point, we need to keep the pitch value as wire dia. And then from second point, the pitch value is wire dia, that is 5. And then from second point to third point, it has to vary from 5 to 25. It has to change from 5 to 25. Okay. And if the third point is having 25 pitch value, and the fourth point again is having 25 pitch value, then it will be constant till here. Then again vice versa, from here 25 to 5 it will get reduced, and again from 5 to 5 it will go, and then just because of this, because it is 5 both the end, it will touch each other. So this is what the whole logic behind this variable pitch inside the helical sweep. I'll just say OK, and I'll go directly for wire dia. Here I will be assigning the wire dia, which is 5. I'll just make it 5. I'll say OK. Now you can see that it is constant here, because we haven't applied the pitch. Now I will apply the pitch in all the points. Now again, there will be start point and end point. This is the start point and end point, and then there are 4 different points which we have already assigned here, we have created here, and all those points will be going by a reference method, so that we can directly select these points. I will directly go for this point, and then fourth point, which is again by reference, which is this one, and then fifth and sixth will be somewhere here. I will again select Y reference method, and I will select this, and then the last which is by reference, and this is the point. So I have assigned all the pitch value for all the reference point. Now the start will be 5, then end will be also 5, then the third point is somewhere here. So this first point is 5, then second point, or here it is showing the third point will be also equal to 5. Then go for fourth point here in the list, which is third point here. So this has to be 25. Make it 25. Now you can understand that from 5 to 5 it is constant, so it is touching, and then from 5 to 25 it is varying, so it start varying from here. Then again, if you see this spring, the fifth point here or the fourth point here will be again 25, then the last point will be 5. So this is how you need to add the variable pitch for the spring. Now I'll just say OK. Now you can see that your spring is almost ready. Then just select the top plane and try to make it ground. Solidify it so that it will remove the material. Now you can see that it is removing around 290 degree. Say OK, and select this plane also and say solidify and remove that. So now you can understand that why I created this plane. This plane I created to make the spring grounded and to assign the spring height with reference to this plane, so that when I make this spring flexible, this plane should move along with the spring, and all the time my top end should be grounded.
Now let's have a small break, and meanwhile you can like this video and subscribe my channel. Thank you.
Now it is the time to assign some relation to the spring before making the spring flexible. But before that, let us rename some of the things, like okay, so I will go for this dimension properties. But before this, just go for renaming and copy this, and now go for dimension properties and make this DO as spring height and say OK. Then some other things like your location is this one. Okay, so here I will rename, see this area is like my ground area, so I will just go for properties and I'll change it as ground. And then in display I will make it symbol, and this point and this point are my location, and this is made equal here. So my location 1 or point 1, I'll just go for properties, I will make it point 1, and here also symbol, so OK, and this also as point 2, and here I will make it symbol. So I have renamed my two locations as point 1 and point 2, and the starting area is the ground area. I just isn't it? Other than this, I will just rename this pitch. So this is the first one. I'll just go for properties. It is showing D11, so I need to rename as pitch, P-I-T-C-H, pitch 1. This is my pitch 1. Okay. And then this is pitch 2. Pitch 2. Okay. This is this I'll leave. I will make this as pitch 3. This as pitch 4. Okay. This as pitch 4. And then this one I will make pitch 5. Pitch 5. And then the last one is this, and this one I'll make pitch 6. Say okay, regenerate and save it. But before saving, okay, I can save it. Before saving, I'll just add the relation. We'll go for tools, relation. Now see, first relation I will give from the location. I'll just select these things. So first is my point 1. So point 1 will be always equal to y dia because it has to touch. Okay, so I will make it equal to y dia. Okay, sorry, here I haven't renamed this y. So this has to be y dia. I will make it y dia underscore dia, and this I want to see as a symbol, so I will make this. Okay, regenerate and save. Now I will directly jump to relation, and here again I will select this. I'll say done. Then point 1 is the first location, is equal to y dia. Then second point 2 is also equal to y dia. Here you can make point 2 equal to point 1 also, but this is the easiest way. Everybody can understand why it is y dia. So these 2 points, because it has to touch, then it has to be y dia. The location, this is the gap distance I'm specifying by this relation. So from here to here also this gap should be equal to y dia. Okay, so location is done. Now I'll say enter. Now the pitch value by this relation. So I'll just go with this, the first one. So pitch 1 will be equal to y dia. Okay, and then pitch 2. From here it is 5 and here also it is 5. That is why it will be touching. Then this pitch will be this is not the y dia. From here to here it is y dia. It is 5 to 5. Here it is 25. So that relation will be somewhat different. So again for second pitch is this, pitch 2 is equal to y dia. Then third pitch is my this pitch. Okay, third pitch. This is also equal to y dia. And then the fourth pitch, this one, is also equal to y dia. Okay, so then I'll just enter in. Then this one, the pitch 4. Pitch 4 is not equal to y dia because it is 25. So the pitch 4 is dependent upon the total height of this spring. So the relation will be pitch 5 is equal to, I need 25. The total height is 100. So if I make it 100 divided by 4, then it will become 25. So I'll just click this spring height and I'll say pitch 5 is equal to this. divided by 4. And this pitch 6 is also same. So pitch 6 is equal to spring height divided by 4. Now this logic you can understand, I believe. Then the grounded area. The grounded area has to be related with the relation. So I'll say ground is equal to, it should always be 30% of wide area preferable. So make it relate with wide area. So I'll make ground is equal to wide area multiplied by 30%, which is 0.3. So my relation is done. I believe I'll just verify everything looks okay. And then I will add one text here on the top. Okay. So this is the text. The text says wide eye is the minimum pitch required to ground the coil. And then location 1, or I can say point 1, P-O-I-N-T. Yeah, point 1 is equal to wide eye into number of grounded coil. So here I will tell you why I am doing this, into 1. Okay, it is very interesting. I am just trying to make this point equal to wide eye into 1. So point 1 is the gap between this. If I make 2, then this gap will be double. If I make 3, then this point gap will be triple. But this point 2 will be same wide eye, it won't change. So if I want to add some more grounded coil, just like this spring, you can see here, this is having 3 coils in both ground ends. So if I need something like this, if I need 2 coils here, then that will be very helpful. So come to the spring 3. So I have done all my relations here. You can see once again. Say OK, regenerate and save. Now let us try the relation. So if I change the dimension of this, I will make it 50 and regenerate. Now you can see that pitch is getting reduced, because if the pitch is 100, sorry, if the height is 100 and then pitch is 25, then now the pitch should be 12.5. So let us go and edit this and see the pitch value. You can see it is 12.5, but top and bottom ends are still 5, and you can see here that nothing is editable because all are driven from our relation. Okay, so now once again we'll try. We'll just change the height of this spring from here to 200. Let us make it 200. What result we are getting? Again you see the pitch value is changing. Now regenerate it. Now if it is 200, if it is when the pitch value is 25, when the height is 100. When the height is 200, then it has to be 50. Let us go and edit this. See what pitch value we are getting here. So you can see that it is 50. So everything looks good. Now let us make this spring as a flexible component and assemble inside a assembly. So make it 100. Okay, so this is my spring. I just reasoned it. You can color this spring as you wish, just like these springs I have colored black and blues, so you can color that. You can go for view and go to new and just edit this. If I want a black color, Then okay, if I want a black color, then I will just play with this. Okay, so select a black color here. Okay, and then apply for this part. So now you can go and edit this sign and other things you can change. Okay, say close, and now same way you can say new, and then you can select the color. This time I will go for light. Say OK and OK and apply for this surface and the bottom surface. Just hold control and say OK. So you have colored your spring. Okay, so now let us make this spring flexible. So to make this spring flexible, we have very nice option inside the file, prepare and model properties. You can see there is a text called flexible here, not defined. So just say change and define it. So in this spring, we all know that the flexible part is the height of the spring. So I will directly jump to height and I'll select this dimension and say OK. So it has applied that flexible property here. Now your height is flexible. You say OK and then you save it. Now the same spring I'm going to assemble in this assembly. Okay, 3 times. So let us hide these 3 springs for time being. So we have 3 different locations to assemble the spring. So let us assemble spring 3 one by one. It is asking for something. Model spring 3 has predefined flexibility. Would you like to use this flexible component definition? Yes, I want to use this. Now it is saying that this 100 is flexible. So which way you want to make it flexible? There are different ways here: curve, length, distance, angle, this, that. So for me it is distance. I will select distance and I'll say distance as this surface to this surface. I say OK. Say OK. Now your spring is flexible. Now just assemble it. I will select the bottom surface to this, and then second constraint is the axis, this axis to this, and this one I will make it coincident. So now see it got squeezed here. Now the second time again I will assemble the same spring. Again say yes, and this time by value. Again I will say by distance, and this time I will select a different distance from here till here. So this is 100. I will say OK. Say OK. And now I will select this bottom surface, which will meet here, and then this to this axis, and again for axis we need to say coincident, say OK, and then the third time I'm going to assemble the same spring. So I will just bring the spring, say yes, then again by distance, and I will sign from this distance, this surface to this surface, and say OK, say OK. That's it. And select this surface to this, and then this axis to this. We'll make it constant. Okay. Now you can see that the same spring is assembled 3 times here, but because this spring is having flexible property, it is following all the surfaces relevant to the position. So this is the way you can make your spring flexible, you can make your spring grounded, and you can vary the pitch of your spring applying the relations. Okay, so now the time is to explain the variable pitch assigning by using by value method. So we will directly jump to spring 1. So this spring is done by using by value method, and if you go for by value method, then even if you're taking this little extra in top and bottom, you need to assign the location or point 1, point 2, point 3 and point 4 by using value. So let us see how we assign that. You need to go inside the pitch and you need to say by value, and then you need to assign some value here. But when you assign the relation, you need to be very careful, because when you assign the by value, uh, when you assign by value, all the value it takes from this point, from this origin. So in by reference, we have referenced the given point from the top and from the bottom. That is why this area is also moving and this area is also moving. But when you use by value method, all points will be assigned from here. Okay, so you need to be very careful when you assign the relation. I will show you what kind of relation I have given. See, if you go for relation, some of the things are almost similar to that. Pitch 1, pitch 2, and these 4 pitch are wide eye, and then the 2 pitch in between is spring height divided by 5. Here it is 20, so I have taken divided by 5. There it is 25, so I have taken divided by 4. But other than these things, the difference is here. Point 1, the first location, is wide eye, okay, by value also. And point 2, since you don't have, since the point 2 is also taking from the same first point, then you need to write wide eye into 2. In a reference method, we can directly take from first point to second point and then second point to third point. So no need to multiply by 2, but here you need to multiply. And then for top location, your relation will be something like this. Point 3 is equal to, first you need to take the spring height, the total height, and from that total height you need to minus this, the wide eye into 2, and then wide eye, this value. Then only it will follow like your by reference method. So this is the relation. This kind of relation is required to use by value method, and that is why the by reference method is most easiest and convenient way to create this kind of flexible spring having variable pitch. And by ratio is the most difficult way, and that is why I am not explaining here, because when you apply the relation becomes more complex, because if you are applying by wire and suppose your wide eye is getting changed, then the ratio changes, because it takes 1 as a complete height, and based on the 1 you need to specify the location in a ratio way, like point 1 will be 10% of the height, point 2 will be 20% of the height. So I think you understood all the concept from this video. I hope this video will be helpful to understand how to make spring grounded, both ends, flexible, and how to vary the pitch based on the flexibility.
So this is it, guys. Now like this video if the video is helpful, share this video with your friends, and subscribe my channel for further updates.